Hi guys, in this part of the unit we're going to look at graphing quadratics. How do we take everything we know about quadratics and apply them to the coordinate grid? That's what we're going to take a look at in this unit, or this part of the unit. So let's go ahead and get started. So we've talked about standard form before of a quadratic function, and standard form is just ax squared plus bx plus c. So our exponents are in decreasing order and our constants are always last. We've dealt with quadratics where a has been 1, and that's where we have to find factor pairs of c that add up to b. And we've dealt with quadratics where this is a number bigger than 1, and that's when we had to do a little bit of extra work. But for our purposes, we're just going to make sure that a does not equal 0, because if a is 0, then we don't have a quadratic anymore. When we start to graph quadratic functions, there's a special name for that graph. It is definitely not linear, but we call it a parabola. And a parabola can be a U shape, it can be an N shape, but what a parabola cannot be is it going this way or this way. These are not parabolas. It has to be one of these two forms. It has to be a U shape that opens up or an inverted U, and we call that opens downward. So there's a few characteristics of this parabola. We have a parabola right here that we want to take a look at, and that's what we're going to focus on for the next week. And the characteristics are the same whether the parabola opens upward or whether the parabola opens downward. And the first is the vertex. And the vertex is the highest or the lowest point on the parabola. I made this a little bigger so I can write it. So the vertex is the highest or the lowest point on the parabola. And it's also called the turning point. So when does the parabola go from either increasing or decreasing? When is the turning point? And so if we have a parabola that opens upward, the vertex would be right there. And if we have a parabola that opens downward, the vertex would be right there. So it's either the highest or the lowest point. And that being said, a parabola has a maximum vertex. We call it a maximum, which is the highest point. It also has a minimum, which is the lowest point. So the parabola that we're looking at has a minimum. So again, highest point, if the parabola opens downward, there's our highest point. If the parabola opens upward, there's our lowest point. So this is the maximum because this parabola is opening downward. This is the minimum because the parabola is opening upward. So if we take a look at our parabola over here, here is the vertex, and this particular vertex happens to be the lowest point because our vertex is opening upward. It's the bottom of the valley. And that vertex is the turning point. So if we're going along on this parabola, it's going downhill. This is where the turning point is, and now the parabola is going uphill. Okay, the other thing we're going to take a look at is called the axis of symmetry. And this is the axis of symmetry right here. And if you remember symmetry from 5th and 6th grade, it's where it cuts the parabola into two equal halves. So this parabola is cut right down the middle. It always goes through the vertex. And if we were to fold this over on that dotted line, we would get two matching halves of the parabola. So the axis of symmetry is the fold line. I'll put that in quotes. That divides the parabola into two matching halves. And when we're naming the axis of symmetry, sometimes we call that the AOS, the axis of symmetry, and it's always in an x equals equation. So if we were to look at this axis of symmetry right here, our axis of symmetry on this example, it is passing through positive 1 on the x-axis, so our axis of symmetry would be x equals 1. That's our axis of symmetry. And the last unit, or the last part, or the first part of this unit, we were looking for the solutions. These are called the x-intercepts, or the zeros. So when we were doing our factoring, this is what we were looking for: our zeros, our x-intercepts, our solutions. So the last thing we want to look at is the value of c. So just like in a linear equation, the value of c determines the y-intercept of the graph. So again, back to our example over here, the y-intercept of this graph is right here, and it is at -3. So eventually we'll look at how can we take all of this information and write an equation, and that's coming in this unit. But for today, we're just going to look at the characteristics of graphing quadratic equations. Okay, one more thing. If we have a quadratic equation where the coefficient of a is bigger than 0, we're going to get a parabola that will open upward, and the vertex will be a minimum. So we'll get a parabola like this, and our vertex is a minimum. So that would be something like if we had a quadratic equation that was 2x squared plus 3. This number right here is bigger than 0, so that automatically means that our parabola is going to open upward. So the opposite of that is also true if we have a negative coefficient. So for example, if I had negative 2x squared plus 3, this vertex right here, or I'm sorry, this coefficient of x squared is -2, so that means our parabola is going to open downward, and the vertex will be a maximum. So it's kind of counterintuitive. So if the coefficient of a is negative, that means our parabola is going to open this way, and then our vertex is right there, so it'll be a maximum. So we're going to go ahead and graph this quadratic equation over here, y equals x squared minus 2. But before we graph it, we need to fill in the chart. We're not going to use our calculator for this. So these are my x values that I'm going to plug into this equation. So for this first one, we're getting y equals, I'm going to square -2 minus 2, and that will give me 4 minus 2, which equals 2. So when my x value is 2 and my input is 2, when my input is -2, my output is a +2. So we'll do the same thing. We'll do -1 squared minus 2, and that's going to give us -1. Then we'll do 0 squared minus 2, and that's going to give us -2. And then 1 squared minus 2 is going to give us -1. And finally, 2 squared minus 2 is going to give us 2. So if you look at these points, you might notice that these two are the same and these two are the same, and this is where it changes over, or this is where we can see some symmetry. Again, the axis of symmetry. So if we start here at -2 and go out, it's -1, -1, then +2, +2, and it would keep following that pattern because that's what a quadratic does. So we're going to go ahead and graph these points. We're going to graph the point negative 2, 2, which is right here. Hopefully we're going to graph, there we go. And then the point negative 1, negative 1, which is right here. Our y-intercept, which is 0, negative 2. And then 1, negative 1, and then 2, 2. And this point right here is in the wrong spot, and it should be right here. So let me see if I can erase that. Yep, it's in the right spot now. And then we're just going to trace it. And a parabola is a curve, so we don't make a perfect V. It has a curve on the bottom. So let's look for a couple things. Let's first look for the vertex. And the vertex in this case is the lowest point. So there is our vertex right there. And the coordinates of that vertex are 0, negative 2. So this is our vertex. And it also happens to be our y-intercept. Now if we're looking for the axis of symmetry, the axis of symmetry is the line that divides the parabola directly down the middle. So we'll use yellow for that. And it has to go through the vertex. So in this case, this right here, the y-axis, is our axis of symmetry. So our axis of symmetry is at x equals 0. This point here, that is the vertex, is also our y-intercept. And our two solutions, they don't go perfectly through, but our x-intercepts are right here and right here. So sometimes the vertex and the y-intercept can be the same, and in this case they are. And our axis of symmetry is dividing this parabola into two equal halves. It's the fold line. And the axis of symmetry is always going to go through the vertex. Okay, so now it's your turn. So multiple choice question 1, what are the zeros for the parabola graphed below? So what that's asking is, and we talked about this in the last unit, the zeros are also known as the solutions or the x-intercepts. So what you're looking for are what are the x-intercepts of this parabola right here. And then question number 2, what is the axis of symmetry for the graph in question 1? So you're looking for the axis of symmetry. It's the line that folds, the fold line of the graph. And the axis of symmetry is always going to be written as x equals. So see where the axis of symmetry passes through the parabola, has to pass through the vertex, which is a maximum or minimum, and then it's written as an x equals equation. Be sure to put your answers on the Google form, and if you have any questions, put that in part 3 on the Google form.